and put a y right there. So it's y equals 2 over 3x minus 2. Now, if you were to go to graph this, there's different ways to do it. There's actually a really fast way to do it if you know something about slope-intercept form. But I don't want to go down that road. I want to do the basic. I want to do the very basic of basic. Meaning, if you went into a 4th grade classroom and gave them this function, or this equation right here, they should be able to do it. Because what you should be able to do is just take x and y values, or take x values, plug them in, and then find your y values. So, let's draw a little graph. Let's draw it right here. This is where our graph's going to go. Now, I kind of want to cheat though. And what I want to do is I want to pick x values that will make pretty numbers. No fractions is what I mean. So give me an x value. See if anybody guys can give me an x value that would make a pretty number. 1? You think 1 will? Let's see. If I plug in 1, it'll look like this. Y equals 2 over 3 times x minus 2. And if I plug in 1, that means I'm going to put 1 right there. What's 1 times 2 over 3? 2 over 3. That's not pretty. I don't want a fraction anymore. Sydney?
So wait, does it matter if the x is a fraction?
No.
Okay, so
Oh,
3 is
yeah, well, if the x is a fraction, you want to multiply by the reciprocal, huh? Like 3 over 2? That would work. But, yeah, but then I have to know where 3 over 2 is on my graph right here.
It's just a little bit above 1.
That's true. I mean, I know that, but I want prettier numbers. I'm really surprised no one's saying 0. Can someone say 0, please? Say 0. Thank you. Yes, 0. What's 2 over 3 times 0? Haha, yeah. So I got 0 equals minus 2, or equals 0 minus 2. So that equals what? -2. Yay. Okay, so I get a 0, -2, so that's going to be right there. You guys with me? You with me? Okay. Can you guys give me... Okay, I'm just picking x numbers and plugging them in to see where the points would be. Because I want to get a general idea of what this function looks like on a graph. So I got to pick some points, pick some numbers to plug into this, some x numbers, to see what my y numbers are so I can get some points. So can you guys think of another number that I could use for x that would make this pretty and nice? I love killing fractions. If you know how to kill fractions, you know that if you multiply it by the denominator, like a 3, the 3 is the denominator, right? Then the fraction will get eliminated. So it look like this: y equals 2 over 3 times 3 equals, or minus 2, sorry. And then I put this over 1, so then I multiply. See, that'd be 6, right? 6 and then 3. And what's 6 over 3 gonna be? 2. Yeah, dose. And so this is 2 minus 2. Oh, that's so pretty. You guys see that? See how nice that is? I like pretty things. Don't you guys like pretty things? I like pretty things. Okay, give me one more. Instead of 3, give me another number that would be pretty. 6. 6 will work. See, if I plug in 6, it'd be y equals 2 over 3 times 6 minus 2. I make the 6 over 1. I cross cancel this time. Divide the 3 by 3 and I get 1. Divide the 6 by 3, I get 2. So it's 2 times 2. That's 4 minus 2. I know I'm going really fast. But this is not like the lesson part. This is like the, hey, check this out. Now, how about this? So I'll get to the how about this in a second. So 4 minus 2 is 2. And so now if I graph these, that's 3, 0. 3, 0, that's 3, x is 3, so I counted over 3, 1, 2, 3, and then y is 0, so I don't go up or down, I just stay right there. This is 6, so I go 1, 2, 3, 4, 5, 6, which is right here, and then I'm going to go up 2, and look, oh dang it, I get a line. Oh, so pretty. Now what's really neat, the more x numbers that you pick, the more points you'll get, but all those points will be on this line. Okay, that's what a function looks like. That's a visual for you, and that's something that you guys should have already seen before in your life at some point. So now, how is that going to apply to this? Well, because we're dealing with the trig function, I put up our unit circle right here to kind of help us with it. I want to pick some nice pretty x values to go into there that give me pretty answers. And when you look at the unit circle, there's not a lot of pretty answers. I mean, look at all these fractions. They're not pretty. What about these numbers? Are those pretty numbers? It depends on your definition of pretty. Okay, so let's get rid of this f of x because I know some of you guys like to see why they're better. So I have sine of x. Y equals sine of x. So here's my table, x and y. What are some x values that would give me pretty answers? Now remember, your x values for this one, because it's inside the sine, they're measures of angles, okay? And because we're doing this on a regular x, y, like Cartesian plane, we have to use radians. We're going to use radians for a unit of measure. So that means you're not going to, like if you were to pick 45 degrees, you're not going to pick 45 degrees. You're going to pick pi over 4, okay? You guys got that? Okay. So, what would be the first angle that you'd want to plug in? 0? Oh, you're so smart. Okay, so if I plug in 0, check it out. I look at 0 over here. And I think you guys remember this now. You look at this, these coordinates right here, and you remember, hopefully, that cosine is your x and sine is your y. You guys remember that? Okay, so if I have y equals sine of 0, what is sine of 0? We look at 0. We look at the y. Sine of 0 equals? 0. What's the next x value that you guys would want to pick? Pi over 6. That's a good answer because you can see that it's 1/2. And it would work. It would work. You can use that. It's fine. But I'm going to try to pick the common points that, like textbooks like to pick when they show you this, okay? So it would work. It would work. Okay, good job. And I wouldn't really want to pick pi over 3 because then it's rad 3 over 2. You have to plug that in your calculator, find out approximately what the answer would be. But look at this one. Pi over 2. If I plug in pi over 2, what is sine of pi over 2? It's 1. Right, it's the y value. So if I plug in pi over 2, I would get 1. It would look like this. Y equals sine of pi over 2. And you guys know that sine of pi over 2 is 1. Okay, now next one I want to pick is going to be pi. So we're going to jump over here, write pi. What is sine of pi? So let me write it out. Sine of pi. And so for that, you look at the y value. It's 0. I heard that. Good job. Then we have 3 pi over 2 is the next one I'm going to look at. These are all the quadrantal angles. Such a weird word, quadrantal. So, what is sine of 3 pi over 2? Negative uno. There he is. Negative uno. Okay. One more, because I want to do a complete cycle. To do a complete cycle, you gotta go all the way around a unit circle. The next one to pick would be 2 pi. And you can pick other values. I'm just picking the ones that don't give me any fractions. So 2 pi, if I plug in 2 pi to sine, I get 0. Okay, so now let's see what the graph looks like. I'm going to make that 1. I'm going to make that negative 1. This is going to be 1, 2, 3, 4, 5, 6. And we'll put a 7 right here too. Okay. All right. Now, 0, 0. That's not a problem. That's actually pretty simple. 0, 0. If that was a point, it's just the first point is right here. All right? No problem? 0, 0. Okay, but this one, we kind of run into an issue. Pi over 2 and 1. Well, I know where 1 is. 1 is right here. But where is pi over 2 on the x-axis? Halfway. Have your calculators? Go pi divided by 2 and tell me what you get. 1.5, so it's about right there. This is pi over 2. It's right between the 1 and the 2. You guys see what I'm saying? Okay. Now, most of the time, you don't write all these numbers right here. You just care about these numbers because those are critical points for this trig function. Pi over 2, y equals 1, so I can go up here to the 1. And then the next one is pi. And you guys know what pi equals. What does pi equal? 3.14. So we're going to the 3 right here, and we go a little bit more than the 3, and that's going to be pi. And that's, see, at pi, we're at 0, so I don't go anywhere. I stay right there. I put my dot right there. You guys with me still? All right, cool. The next one is 3 pi over 2. Can you guys punch that in your calculator? Go 3 times pi divided by 2. What do you get? What do you get? What do you get? What do you get?
4.7.
Yeah, it's not 1.5. We shouldn't get 1. You got 4.7? That sounds about right. Go 3 times pi, then divide it by 2. Okay, you got 4.7? So it's right about there? Wait, is it 4.7?
Yeah.
Okay. Okay, 3 pi over 2. Okay, so that's 3 pi over 2. And at 3 pi over 2, it goes down to negative 1. So I put my negative, my dot right there. And then what is 2 pi? That's my last one, 2 pi. 6 point, what? 28? Yep, 6.28. So I put 2 pi right there. And at 2 pi, y equals 0. So I put a dot right there. And so look at that. Wow, dots are like all over the place. When you guys graph or connect the dots for sine, make sure it's curvy. It should look like this. And all I did was graph a cycle before it starts repeating itself. Okay, this actually keeps going like this all the way. I mean, it'll look a lot nicer, but I just graphed a cycle, and for this cycle I stopped at 2 pi. That's also known as a period, but we're going to get more into that in a second. I want to give you guys a chance to graph cosine on your own. Before I give you guys the cosine one, let me show you what sine looks like on a big graph, like just so you can see that how it goes on forever. So this is what the graph looks like if you were to keep graphing it. But